Hello everyone, welcome to ATM101 Unit 14. My name is Andrew Lang here at the University of Alaska Fairbanks. Today we will be discussing climatic influences on observed weather at two different sites in Alaska, Valdez and Northway. There are climatic variations in daily temperatures as well as seasonal temperatures overall as an average due to a variety of factors. One of the most dominant factors is proximity to a body of water. Water as a whole is less responsive to solar heating and radiational cooling, and this is why temperatures, for example, in Northway as a whole, especially during the winter months, but also during the summer, swing more wildly even in the course of one day than they do in a location like Valdez. Mountain ranges also play a serious role in that they physically wall off an interior region from the coast. In doing so, they can also create the so-called rain shadow effect, which has been previously discussed. Given this effect, locations on the leeward side of such mountains, such as Northway, inland from them, generally experience less precipitation and thus a drier climate and more high-pressure systems and fair weather. You can also get the so-called Chinook or snow-eating winds, which can lead to events such as the higher than normal observed temperatures in March. Obviously, these winds are referred to as snow-eating because they can bring extremely warm temperatures to interior areas even in the middle of winter. Here is our physical location map. Here is Valdez, which is near the coast, a large body of water, obviously the Gulf of Alaska in the Pacific Ocean, and Northway, which is near Tok. For reference, Fairbanks would be about here, and Anchorage would be about here. And Northway is physically isolated from the coast by two mountain ranges, the Wrangell Range and the Chugach Range. Given this, it is effectively walled off from the coast and will therefore experience a continental climate, whereas an area such as Valdez will experience more of a coastal or maritime climate. As previously discussed, high-pressure systems result from convergence above, hence falling air, and low-pressure systems are the opposite of this. Low-pressure systems are generally associated with storms and precipitation, and high-pressure systems are generally associated with fair weather and clear skies. Low-pressure systems cause precipitation because as warm air rises, it cools, thus allowing condensation and dew point to be reached, hence why clouds form and precipitation occurs. Whereas the opposite happens with falling air, and you do not get this as much. Here's just some imagery from 4 different days this year, 2 days in one day in January, late January, 1 day in early February, and 2 days in mid-March, exploring the satellite imagery and what weather systems were affecting an area at a given time. On this particular date, which was January 30th of this year, 2018, both locations were largely experiencing a low, however there was a warm front and a cold front both occurring. Overall, Valdez and Northway still had substantial differences in temperatures, particularly in January, in that in Northway, the swing between warm and cool, high and low, was much more dramatic than in Valdez. Additionally, the low temperature was much colder in Northway than it was in Valdez, and the high temperature was not physically warmer in January, given the fact that it is a colder region to begin with. And especially in the dead of winter, the deep cold of January, the interior of Alaska is, if anything, cooling due to radiational cooling, whereas during this time the water remains warmer than the land as it is much less responsive to radiational cooling. Also, often low-pressure systems bring cloud cover, which can bring cloud cover as water vapor, which acts as a greenhouse gas, therefore preventing some of the radiational cooling from occurring over water, thus amplifying its effect, or causing a negative feedback cycle, rather. Here is February 2nd of 2018. As can be seen during this time, here are our two locations. They were under the influence of a high-pressure system. Some cloud cover can be seen moving out to sea. However, this would have brought clear skies to the area, which would have resulted in increased solar radiation to these locations, which in a location such as Northway may have resulted in an albeit slightly warmer day than it would have otherwise been. This may have also been true for Valdez, but to a lesser extent. Finally, on Monday, March 19th of 2018, sticky key, we see there is a warm front and a cold front both occurring in this area. There is precipitation and snow happening off the coast, particularly in Valdez. However, Northway appears to be in the clear and experiencing generally fair weather during this time period. If anything, there was some amount of blowing snow, which would have caused cloud cover and would have prevented further cooling than a clear day would have caused. Finally, on Friday, February 2nd of 2018, both areas were under the influence of a high-pressure system. Given this, one would assume that the weather would be fairly clear and fair weather, and as previously discussed, some solar warming would have occurred. Especially given that this is getting a little bit later, but not into March yet, you would assume that as the days go on and the sun angle becomes higher in the sky and the days become longer, that radiational warming would have more of an effect. Finally, in March, an entire month and some later, we see there are several low-pressure systems in the area on those given days. Snow appears to be occurring in both Valdez and Northway at this time, and there is a cold front occurring. Finally, on March 24th, we can see that there is a high pressure and a low pressure in the general area. Northway and Valdez are closest to the low pressure, the 1004 millibar system, than they are to the 1032 millibar system. Therefore, they are likely to experience clouds or fog or precipitation. However, especially by this time of year, Northway is going to have a more dramatic temperature swing and likely be somewhat warmer, if anything, than Valdez, due to the fact that it is more responsive to solar radiation and warming, and its low temperatures over the course of overnight will indeed be lower due to the benefits or effects of increased radiational cooling, given that land is more responsive. It should also be noted that although it would not have been occurring yet, once the sun angle in the sky and the hours of sunlight per day reach a certain tipping point, snow begins to melt. Once snow melts, the land's albedo decreases in that it is less reflective and absorbs more heat more quickly, thus causing snow to melt and temperatures to increase dramatically in the spring at breakup. As discussed, solar radiation plays a role, and this can in turn affect the temperatures of land and water. The dew point is generally reached overnight as air cools, obviously. Air keeps cooling during the night, radiational cooling, until generally all other factors held constant early morning or shortly before sunrise. Here is just a screenshot of some station data. Now, without going into the numbers, the most obvious change is that in Northway during this time, the temperature swings, even from day to day or hour to hour, are much more dramatic than they are in Valdez. The pressure observations are generally the same because only 200 miles from each other, they were experiencing overall the same weather systems, even if the observed weather actions or the observed effects of the weather were somewhat different. Similarly, the same pattern can be observed with dew point, in that it was much more dramatic in an area such as Northway than in Valdez. The same generally holds true in March. As we can see, Northway's temperature swings are much more dramatic. Here are some averages plotted out. So if anything, the low temperatures were below average and the high temperatures were somewhat above average, especially toward the beginning. This could have been possible due to effects such as Chinook winds or cloud cover. Cloud cover is water vapor, and water vapor itself acts as a greenhouse gas in that it can also slow down radiational cooling. Given this, days that are cloudy, this is partially why clouds act as an insulator and less cooling is experienced, or in the dead of winter or on cold nights generally, cloudy nights or cloudy days can be generally warmer than clear days. Of course, in the summer or with extreme amounts of daylight, the opposite is true, in that clouds block solar radiation, thereby resulting in cooler days. So much like a body of water, clouds can also mediate temperatures. Here we just have some satellite imagery from the 4 days. The most appreciable one is the water vapor. As can be seen on January 30th, clouds were definitely being observed, especially out to sea, as previously mentioned. The infrared is also interesting to note that generally the land remains warmer than the water does. Or, excuse me, the water remains warmer than the land. The land is colder than the water. This is because, as previously discussed, water is less responsive to temperature changes than land is. It is not as responsive to solar heating or radiational cooling. Here is just some visible imagery, and seen here is some amount of cloud cover, which would have been impacting areas such as Valdez, more so than Northway, which would have been about here in both images. Generally, the same idea holds true for our next slide, the same dates. Water vapor has moved inland by this time. During this time, as seen throughout 1 week, temperatures dropped off. This would have been likely during the day due to less solar radiation. However, the night temperatures would not have dropped off as much due to the fact that clouds act as an insulator and as a greenhouse gas. As seen here, the water is generally somewhat warmer than land, hence why Valdez experiences less extreme temperatures as well, particularly warmer, low temperatures. Finally, going into March 19th, we still see the same patterns as discussed, generally speaking, as can be seen here, going throughout that next week. Northway was under the influence of some cloud cover, hence it would have likely experienced cooler days and warmer nights than with clear skies. And finally, on March 24th, we generally see the same patterns. At a certain point, it is worth noting, as mentioned previously, that melting snow decreases land's albedo, thus causing it to absorb heat more readily and therefore warming more rapidly during the spring months than a coastal area will warm. This is why in interior Alaska temperatures jump dramatically in the spring as soon as snow begins to melt. Finally, just to drive this effect home, here are some screenshots of just monthly average climatic temperatures for Valdez and Northway, respectively. As seen here, Northway's temperature changes are more dramatic, particularly the winter lows. Summer highs are similar, although not identical, but winter lows easily have a difference of as much as 50 degrees Fahrenheit. As discussed, different areas have different sensitivity to climate change. As has also been discussed, places like the Arctic are especially vulnerable for other reasons. Northway would be more sensitive to climate change overall than a place like Valdez would, because the ocean mediates temperatures. A place like Northway might experience increased growing seasons or increased snowmelt in the spring due to global warming, or global cooling would be more likely to cause things like cooler average temperatures and more snow in a decreased growing season than Valdez. Of course, the argument always comes up about a location such as Valdez flooding. However, that is not a weather event. The weather would be the same, likely, or very similar in such an area.